Hello everyone, today we're going to be doing some Blind 75 C++, and today we are focusing on jump game. Now, before we get started, we need to know how to break down our problems, so I'm going to write out our 4 questions of what we need to go over. You need to ask yourselves what the input is, what data structure / algorithm / technique to use, what to do with the data, and then what our output is going to be. So, pattern accordingly. So, you were given an integer array nums. Already up here, it's highlighting the parameter. Okay. It's called nums. You were initially positioned at array's first index, and each element in the array represents your maximum jump length at the position. Return true if you can reach the last index, or false otherwise. So, going over the example 1, is it possible to jump from the very first index and all the way to each element accordingly. Okay, and each element in the array represents your maximum jump position. Okay, right here. Okay, yeah, right there. That's pretty straightforward. So we have this 3, 0, false. You can't because it's 0. Makes sense. All right, and the jump for output is going to be return true if we can make the jump, false if we cannot. So looks like for this entire thing we will be using the greedy algorithm. And what are we going to do with the data? Well, three, 4, 5. Alright, so one, we need to overall traverse the array from right to left and maintain a last position, which is initially the last index, and then if the current index plus the value at the index is greater than or equal to the last position, we update the last position to be the current index. So how are we going to do this? Well, based on the number of steps we are going to do, which is going to be 4, we're going to initialize the last position to be the last index of nums, and then we are going to traverse through the array from left to right, and then if the current index plus the value at that index is greater than or equal to the last position, update last position to be the current index, so that way we know exactly if we have attained our maximum jump. And then finally we will return true if the last position equals 0, otherwise false. So we're going to first do our last position equals nums.size -1 Over here, then we're going to do step 2. We are going to iterate through our entire array. 0 is going to be equal to nums.size. -1, since we're going from the rear, equals 0. And then I minus minus over here. Then step 3. If I, like, for example, hang on, I'll write this out and be able to showcase what we have. I is going to be greater than or equal to last position. Then we're going to have last position equal I, which is the current index. Finally, return the last position equal to 0, where by default booleans will be true in C++. Okay, so it's pretty self-explanatory over what we have, since the reason being that we're starting from the very last index is that in order for us to be able to get our maximum what we're trying to do is determine if we, from the very last index, if the jump can be made. So if we were to have, for instance, in one example, we'll put this in here, such as if we have the value of the index of 1, 2, 3. Let's make this 1, 2, 3, 2, 4. We'll determine if it's true. So I, in particular, starting from the very last one, if nums of 1, 2, 3, if we have the third index, since arrays typically start at 0, 3 plus nums of 3, which would be 4, equal to last post, where if it's a num.size -1, over here. So nums.size would actually be 4, since we have 4 different elements inside, -1, which should be 3. So therefore, since we already have 7 is greater than or equal to 3, we are going to be returning true, and the conditional logic already makes sense over here. Everything's already initialized. Smooth there. Alright, and it works. I'm just clean this up so that way you folks can be able to see throughout. Alright, and we are good. And now, just to be able to give a rundown of our space and time complexity over what we have. So, given the fact that we're using a greedy algorithm, they're naturally pretty efficient in terms of space complexity because they just scan throughout the rest of the array. The principle behind it mostly focuses on finding every single possible element that we have in our given array or data structure. And since there's no data structure to be able to store any of the information that we have passed through, the space complexity is going to be linear, O of 1, while we are running on constant time O of n because n represents the size of the array. So yeah, this was Jump Game on C++. This is another subfield of dynamic programming as well. Thank you again for taking time to watch this. If you have any other questions in the meantime, feel free to put them in the comments section. And if you also like this, feel free to like and subscribe. And as always, take care. Cheers.